Welcome back to part 3 of our chapter 1 function review for Calculus 1. We just finished up a function transformations review, so now we need to talk very briefly about properties of logs, and then we will talk very briefly about difference quotients, and then we'll be finished. So before we talk about properties of logs, we should talk about properties of exponents. Exponents have 3 important properties. Well, exponents have lots of important properties, but there's 3 that we're going to talk about today. Most people remember this one as same base add the exponents. I don't like thinking about it that way because that implies that it is directional, that you're always going from this to this. That's not always true. Sometimes we want to go backwards. Sometimes we want to take one exponential expression and we split it up into 2. Like if you start with something like 2 to the 12th, maybe you want to split that into 2 to the 10th times 2 squared. I don't know offhand what 2 to the 12th is, but I know that this is 1024, and I know that this is about 4. So I can pretty easily figure out that this should be about 4,000. So you can go both ways with this. My name for this is multiplication outside. That's what this is. This is multiplication outside of an exponent. Is the same as addition inside. And this is a property of exponents. Another property of exponents we have is basically the same as this, but with division. A to the x over a to the y. It's going to give us a to the x minus y. So this would be division outside is the same as subtraction. Inside. And if you know this first property, and you know what negative exponents mean, like this is the same as a to the x times a to the negative y. So it kind of makes perfect sense that this should be a to the x minus y. These are, in a sneaky sort of way, these are actually the exact same property, just with negative exponents instead of positive exponents. But we can write it down twice. The third and final property that I want to talk about is a to the x raised to the y is a to the xy. And this one I call exponents outside is multiplication multiplication inside. So again, this multiplication is happening inside the exponent. This exponents are happening outside of the other exponents. These are the 3 properties of exponents. With these in mind, we're going to talk about properties of logs. Properties of logs, there are 3 of them. They look almost exactly like what I just wrote for the properties of exponents, but with the pieces sort of transposed, like half transposed. Like they're going backwards and in the opposite place. So let's talk about what that looks like. The log of a times b. So now we have multiplication on the inside. This is going to be the same as the log of a plus the log of b. So this is multiplication inside is the same as addition outside. So this is mostly the same as our first property of exponents, except that the operations got switched. And I want to emphasize that because you have to be very careful about not confusing these things. Lots of people try to do something like log of a plus b is log of a times log of b, and that is incorrect. That is trying to use an exponent property on logarithms. Doesn't work. It's never going to work. Don't try to do that. You have to be very careful about which properties work for exponents and which properties work for logarithms, which is why I'm saying it. So, we have multiplication inside turns into addition outside. Some of you can probably guess that the next one is going to be a division one. Division is going to turn into subtraction. Division inside is the same as subtraction outside. And then the last one is with the exponents. The log of a raised to the b is b times log of a. And this one deserves a note of special consideration because it's different from these guys. In these two, both of these pieces have logs. This is log a minus log b. This is log a plus log b. When we split this up, for these first two properties, when we split it up into two pieces, both of the pieces get logs. We're not doing that here. When you pull an exponent down outside, it doesn't get a log. This isn't log of b times the log of a. It's just regular old-fashioned b times the log of a. There's no second log in this property. So, to illustrate that, I use a special word for this. I will say exponents inside. Oh, this shouldn't be an equal sign. This should be an equals, not a whatever this symbol is. Exponents inside is coefficient multiplication outside. I use this word coefficient to suggest that you should not involve a second log. Just use b, use whatever this exponent is, use that as a coefficient, and then you're done, and that's it. These are the properties of logs. If you want some examples for how to use these, check the homework. I got tons. You're in luck. That's it for this video. We got one more incoming. It's going to be about difference quotients. They're very exciting. Don't miss that one.